Hello students, welcome back. We're going to continue today with Lipids Part 4. Forgive my appearance today. It's kind of early in the morning and I decided to try to come in and get a video done before I went to exercise. And so this is going to be Lipids Part 4. Okay, let's review what we've discussed already. Going back to our lipid-associated molecules. We've discussed fatty acids. We know the 9 fatty acids we need to know. I'm going to put that list on the screen at some point. Glycerol, we know what glycerol is. We know that the two terminal carbons of glycerol, they're not the same. Based on stereochemistry, they are different. And so in this video, we're going to look at diacylglycerol and our triacylglycerol. So we're going to take glycerol and we're going to attach fatty acids to glycerol. Now, triacylglycerol, this is fat. This is how fat is stored in all organisms. And so we'll look at that first, and then we'll look at diacylglycerol. Okay, let's begin. Okay, let's go to a new slide and let's draw triacylglycerol. So we already know, let's move this out of the way. We already know what glycerol looks like, so I won't draw the structure of glycerol by itself. I'm going to put here C. So these are the carbons on glycerol. H2OH, H, H, OH. Okay, what I'm going to do here, I'm going to get rid of this H here. Actually, I'm not doing any of this right. Okay, here we are. Okay, this is going to be our glycerol backbone. Now let's attach our lipids. Okay, I have an O here. Attach our fatty acids. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And so that's stearic acid we've added to that one. For this one, we're going to make it really simple. And stearic acid is an acyl group because it's a fatty acid group. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Stearic acid again. And don't know what happened there. Double bind O. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And so on all of these, we have stearic acid, and all of these are glycerol. And so in here, we have, this is glycerol, the glycerol backbone in black, and in blue we have 3 stearic acids, or we have 3 acyl groups, or we could say these are 3 steroyal groups. Okay, and now if we wanted to name this molecule, the generic name would be triacylglycerol. And so this is a triacylglycerol because it's glycerol attached to 3 acyl groups. If we want to be more specific, we could call this one tristeroyl. Glycerol. tristeroyl glycerol. And tristeroyl glycerol is a triacylglycerol. And triacylglycerol, this is fat. This is fat. This is how fats are stored in our body. This is also called tristeroyl glycerol, is also called tristerin. Okay, and this is how fat is stored in our body. Now, these don't all have to be these don't have to all be steroyl groups. We could have a myristoyl group, or we could have a palmitoyl group. But if they're all the same, and here we have them all the same, all of the acyl groups are the same, we call this a simple. We call this a simple triacylglycerol, because all of the fatty acids are the same. And I'm going to stop here on this one. I think we have everything we need to know. Oh, no, we don't. Probably the most important thing. This bond here, we haven't identified this special bond here. Now, if there were, here we have an R group. If that R group were an H, we would call this a carboxylic acid, but it's a C here. And so this special bond, probably the most important bond in biochemistry, this is an ester bond. So this is an ester bond. Okay. Look at my notes and see if there's anything I'm missing. Okay. And this is a triacylglycerol. Triacylglycerols are also known as triglycerides. Triglycerides. Okay, and this is how fat is stored in our body. So if you have fat on your body, it's going to be a triacylglycerol or a triglycerol or a triglyceride. And that's all we're going to say about this simple triacylglycerol. When we come back on the next clip, we're going to look at a complex triglyceride, and this is one in which the three fatty acids aren't all the same. Okay, on this clip we're going to draw a mixed triglyceride, or a mixed triacylglycerol. Same thing. We're going to have glycerol with three fatty acids, but the fatty acids are just going to be different this time. And get this out of our way here. Okay, this is going to be our glycerol, C. Our ester linkage here. And let's make the first one myristic acid. So that's 14. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, our second one. Let's do stearic acid since we did it before. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And for our third one, let's put an unsaturated fatty acid. Let's do palmitoleic. 2, 3. No. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And so here we have, the first one is going to be, this is a the first one is myristic acid. The myristic acid is attached here. And so this group is a myristoyl. The first one is a myristoyl group. The second one is stearic acid. And so the group is a steroyl is a steroyl group, and the third one is palmitoleic acid, and the group is a this is a tough one, palmitoleoyl group. Palmitoleoyl group. And so this, just as before, so H2, this is just as before, is a generic triacyl glycerol. Okay, and if we were to name this completely, it would be, here we go, it would be myristoyl steroyl palmitoleoyl glycerol. And since all the fatty acids are not the same, this is not a simple fatty acid. We would call this a mixed, this is not a simple triacylglycerol. We would call this a mixed triacylglycerol. And chances are most of them are going to be mixed. Most of the triacylglycerols are going to be mixed. And so, nothing new to say about this. Here we have our ester linkage here. That's very important. Ester linkage. We have glycerol and 3 fatty acids. Nothing new here. Nothing new. We have a saturated fatty acid here. This is saturated. This is unsaturated. One of them is unsaturated. And so that's all I have to say about our triacylglycerols. Okay, on this clip we're going to talk about something that you can do with pure animal fat, or just pure triacylglycerols that come from animals. Of course, you can cook with them, and you can cook with triacylglycerols that come from plants as well. But this is something a little different. So, animal fat, pure animal fat, is shown here, and this is called lard. L-A-R-D, lard. And people used to eat this quite a bit. But animal fat has a lot of saturated fats. And so if it's a solid, when you look at it, if it's a solid, it's going to be a solid in your body, and that's going to cause you a lot of problems. But we're going to talk about the eating of it. So if you take something like animal fat and you add it to this here, this is lye. And lye is just sodium hydroxide, and we know what sodium hydroxide is. It's a base. If you add the lard and the sodium hydroxide and you mix them together and then you heat it, and people used to do this a long time ago, quite a bit. People still do it today. And so here we see this lady here. She has in this kettle or this pot, she has lard, which is animal fat, triacylglycerols, and sodium hydroxide. And she heats these together, and what's going to happen? The sodium hydroxide is going to hydrolyze those ester linkages, and you're going to break those esters, those fatty acids. You're going to free those fatty acids, and then the sodium is going to there's going to be an ionic attraction between the fatty acid and the sodium. You're going to have a sodium salt, and then once that cools off, you're left with glycerol and this product here, lye soap. And this is how people used to make soap in the past, and this is called lye soap or lard soap. And so this whole process of making soap using animal fat is called saponification. And this is how people made soap. You take lard, add sodium hydroxide, you heat it up, and then you're going to get lye soap. Now I'm going to show you that the chemical reaction here. Let me move my grandma's lye soap out of the way, and I'm going to show you what the reaction looks like. And so you're going to have 2, 3 O, C. Okay, and here we're going to have our fatty acid here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say muriatic acid. And then you're going to have another one here. Oh, here's our ester linkage. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is our triacylglycerol. This is our animal fat. And so what we're going to do, we're going to add some sodium hydroxide here. And we're going to add some heat. And then when you do that, you're going to create your free fatty acids. You're going to break that ester linkage. You're going to have your free fatty acids here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's 12 of them. So you're going to have 3 of those, but you're going to also have the sodium that's going to be attached to this. So you're going to have 3 of those. And this, plus you're going to have some glycerin or glycerol in here. Okay, let's get rid of that. I don't know what's going on there. And that is your soap, glycerin and your fatty acids attached to the metal sodium in this case. And that's going to be your soap. And this is how people made soap, and they would take baths with soap. We still use it today, but we use it as a cleaning product. We don't really use soaps. We don't really use lye soaps to shower and bathe with. And so here's the process, saponification. Hope it makes sense to you. On this last clip, we're gonna start looking at adding a phosphate to one of the carbons in glycerol and adding fatty acids to the other 2 carbons. We're gonna start to make phospholipids. And so let me just show you the simplest of all the phospholipids. Let's move this out of the way. Oh, let me just show you where we are. We've done the fatty acids, we've done glycerol. We're not going to do diacylglycerol yet because I think you know, since we've done triacylglycerol, just take one of those fatty acids away and you have diacylglycerol. But we're going to just introduce phospholipids. We're going to start with the simplest of the phospholipids. Here we're going to have glycerol, 2, 3, and I don't know, let's put our ester linkage. I don't care what the fatty acid is now, so I'm just going to do this. And that will just represent any fatty acid. This will be any fatty acid because that's not important now. Because I'm not going to be drawing any specific phospholipids. Okay, and so this would be diacylglycerol. This would be diacylglycerol. And what we're going to do here, instead of adding a 3rd fatty acid, what we're going to do, we're going to put a phosphate group. Okay, and so this would be our diacylglycerol, and this would be our phosphate. And so this molecule, this structure, is known as phosphatidic acid. Okay. And phosphatidic acid is a phospholipid. It is a phospholipid. And all of our phospholipids are going to be based on this structure. And so this is one of the phospholipids. So it is a phospholipid. And it's the parent of all of our phospholipids. And so all we have to do now to make all of our other phospholipids would be to attach something here. Attach an R group here. Now, and this makes all of our phospholipids. Let's look at some things here. This is an ester linkage here. This is an ester linkage. And if you'll notice here, I'm going to shade it blue. This is a phosphoester linkage. So this bond is a, oops, can't erase. This is a phosphoester, a phosphoester bond. Okay? And on the other side, here, if this is a C, this is going to be another phosphoester bond. So we have a phosphoester bond here as well. And so if we have two phosphoester bonds, we can call it a phosphodiester. So it's two of them. So both together make a phosphodiester bond. Okay? And so when we come back on the next clip, we're going to be looking at our phospholipids. And phospholipids are found in cell membranes. And so if you have a cell, well, we'll talk about that next time. And so here we have diisoglycerol attached to a phosphate, and this makes phosphatidic acid. And if we start changing this R group, then we start making other phospholipids. And we're going to stop there for this clip, and we're going to stop here for this video lecture. Hope everything makes sense to you.